Today we will be doing linear programming using word problems. The following exercises, these are the 4 steps you need to do. We are going to identify and write an objective function and the constraints on that function. We're going to graph the system of inequalities representing the constraints. Then we're going to find the value of the objective function at each corner of your graphed region. Then we're going to use those values that we find in part B, or C actually, to determine the maximum value of the objective function and the values of x and y for which the maximum occurs. Okay, now I know it's 1 problem per page, but I will tell you right now it might take you using extra paper today to do these problems, because even though I've given you room, there's still not enough for some of us who write large like me. Now, here's our first problem. Example 1 states, in 1978, a ruling by the Civil Aeronautics Board allowed Federal Express to purchase larger aircraft. Federal Express's options included 20 Boeing 727s that United Airlines was retiring, and or the French-built Dassault Fanjet Falcon 20. To aid in their decision, executives at Federal Express analyzed the following data. They found that the direct operating cost for the Boeing was $1,400 per hour, and the payload on the Boeing was 42,000 pounds. And for the Falcon 20, the operating cost was $500 per hour, and the payload on a Falcon 20 was 6,000 pounds. So, Federal Express was faced with the following constraints where this was concerned. Hourly operating cost was limited to $35,000. Total payload had to be at least 672,000 pounds, and only 20 727s were available. Now, they've given us our constraints, and they've told us how to find our objective function. So using this information, we're going to follow our steps, and we are going to find out how many aircraft of each they should purchase to maximize their number of aircraft in their fleet. So the first thing we do is we need to identify our objective function. Our objective is to get a maximum number of aircraft. So we need to identify our variables. Obviously, the aircraft is our variables. So we're going to identify our Boeing as our X values and our Falcon 20s as our Y values. Now that I've identified my variables, I can write my objective function. To maximize the number of aircraft, I need a combination of the Boeings and the Falcons, or just Boeings or just Falcons. To write our objective is we want to maximize however many Boeings we buy plus however many Falcon Fanjets we buy. Okay? So there's my objective function, x plus y. Now, my constraints, it's real simple here because they tell you these are the constraints they face. So all you have to do is read each bullet to get your constraints written. So my first constraint deals with my hourly operating cost. They say it's limited to $35,000, which means it can't be more than that. So I know part of my constraint is it has to be less than or equal to $35,000. Okay? What has to be less than or equal to $35,000? Your total operating cost, which is how much it costs to operate each airplane. So, however many Boeings I buy, it's going to cost me $1,400 per plane per hour. So that would be 1,400x plus however many of my Falcons I buy times 500. So 500y. There's my first constraint. Now, that one's done. Now go to the second bullet. Your total payload has to be at least, keywords here, at least 672,000 pounds, which means it can't go below that number, but it can go above. So that would have to be greater than or equal to 672,000 pounds. Now, how do I figure out my payload? Well, however many Boeings I have times the pounds each plane can hold. So 42,000 times X plus however many pounds each Falcon will hold. So 6,000 Y. All right, second constraint has been written. For my next constraint, I read the last bullet. It says there are only 20 Boeings or 727s available. Well, that means that my X cannot be more than 20, meaning it can equal 20, right? So if it can equal 20, but it can't be any more than that, so it's got to be less than or equal to 20. But I also know I'm not going to buy a negative number of either of the planes, right? So I also know that my number of Boeings has to be greater than or equal to 0, and my number of Falcons has to be greater than or equal to 0. So I also know that X is greater than or equal to 0, and Y is greater than or equal to 0 are my other constraints too. So now we have all of our constraints. Now we can start the process to getting to where we can graph them to get our feasible solutions. And this is where the extra sheet of paper might just come in handy. Okay, so I am going to start by solving for Y any of my constraints that are not solved for Y. So my first constraint was 1400X. Of course you can't see that. Plus 500Y less than or equal to 35,000. Okay, so let's start solving for Y. So I'm going to subtract the 1400 to the other side. So 500Y is less than or equal to negative 1400X plus 35,000. Then divide by your 500. You'll come up with Y is less than or equal to negative 2.8x plus 35,000 divided by 500 gives you 70. Okay, from here I know that my y-intercept is 0, 70. Okay, now I'm going to leave that here and I'm going to start working on my second equation. 42,000x plus 6,000y greater than or equal to 672,000. Okay. Again, subtract your x over. So 6,000y greater than or equal to negative 42,000x plus 672,000. Divide everything by the 6,000. You're going to come out with y is greater than or equal to negative 7x plus 112, which tells me my y-intercept for this particular function is 0, 120. Okay, now that my computer is working again, once we have our y-intercepts, if I look at the graph that these are supposed to go on, give me 1 second. There seems to be a problem with our graph, right? Our graph only goes to 10, and my y-intercepts are obviously more than 10. So what I need to do is I need to think of what kind of increments can I put these 1 through 10s in that would be able to let me graph 70 and 112. Well, if I look, what if I made this 1 through 10 in 10s, which means 1 is 10, 2 is 20. And I did the same thing on the side. Put this in 10s. Then I would be able to graph, right? Okay? But herein lies the problem. When you do your slope from your y-intercept, you're only going down 7. Kind of hard to do that in increments of 10. So what I recommend doing is finding your x-intercepts also. Okay? And your x-intercepts are when your y value is 0. So if I was trying to find my x-intercept on my first equation, I'm going to use the y is less than or equal to negative 2.8x plus 70, but I'm going to plug in 0 for y, and instead of using the less than or equal to, I'm going to just use equals negative 2.8x plus 70. So I solve for x now. So negative 70 equals negative 2.8x. Divide by 2.8, and I'm going to get that my x-intercept is at 25. Now I have 2 points I can plot on my graph here in just a second, and I will get my full line. Now I need to do the same thing over here. So I need to find my x-intercept for my other constraint. So 0 equals negative 7x plus 112. So negative 112 equals negative 7x. So x ends up being 16. So my other equation has an x-intercept of 16. Now I'm ready to start graphing. I'm going to use different colors when I graph these today. So I am going to make my first constraint. That equation is going to be my purple line. Okay? So now I'm going to go to my graph. I'm going to graph. Hold on, let me zoom out a little bit so you can see this. I'm going to graph y is less than or equal to negative 2.8x plus 70 by graphing the y and x intercept. So my y-intercept is at 70. Again, I put these as in 10s, so 70 is going to be real easy. I go up here to 7, that's 70, and I make my point. Then my x-intercept is at 25, so I go down here, and 25 is right in the middle. Okay? Now looking at this, it's less than or equal to, so no, I know I'm solid, and I'm shading below. Okay? So now I take a straight edge, and I make my line. Draw my line. Okay? Then it's below, so I draw my arrow pointing back below. So far this isn't so bad, right? Okay. Next, I'm going to do my second constraint, and I'm going to use red on him. Okay, so now let's start graphing the red, my second constraint. My y-intercept is at 112. When I look at my graph, it only goes up to 100. But I know the next dot would be 110, and it'd be just a little bit more than that. Yes, I'm going to kind of have to guesstimate on that part. But I do know my x-intercept. I can clearly graph down at 16. Here would be 15, so go just a little over, and there's my 16. Once I get those done, again, I take my straight edge, and like I did not do just now, it is a solid line because it is greater than or equal to. So connect my dots, and there's my nice pretty line. Okay, now it is solid, and because it's greater than or equal to, we would do above on this one. So I'm going to draw an arrow above, saying, nope, go that way. Okay? Now, I still have more constraints, don't I? Because if I look back at when I wrote my constraints, I still have 3 more to do. So because I have 3 more, I have 3 more colors. X has to be less than or equal to 20. I'm going to put with blue. 20 is at 2, right? Less than or equal to is a solid line. So at 20, I need to draw a solid line going straight up my 20. And if it's less than or equal to, like we see here, it's to the left. Okay? And I'm sorry, that's not blue, that's black. Now I'm going to take orange, and I have 2 more constraints. My other 2 constraints are x has to be greater than or equal to 0, and y has to be greater than or equal to 0. Because both of these mean you can't buy a negative number of these planes, you simply know you've got to come on your axes and draw your lines. Straight on your axes. Okay? Which means I now have my constraints fully drawn, and now I can shade in my feasible region. Now, if I am looking here, my feasible region has to be below my purple line and above my red line. So I'm looking at this region right in here. Okay? Now I'm going to zoom in so you can see it a little better. There is my feasible region. Now, the last thing we have to do is find our vertices when it comes to this graph. And if I look on my graph, I see that I'm going to have a vertice right here, up here somewhere, and right here. Now, of these, there are 2 vertices I know exactly what they are. And that would be these 2 right here. Because this vertice right here was an x-intercept at 16. This vertice right here is at 20. And my y value is 0. So I already have 2 of my vertices right there. The other 2 I need to find using systems. Now, the easy one to find is this one right here, because I already know my x value is going to be 20. I just need to find the y value where this line, the purple line, intersects this line. So my purple line was y equals negative 2.8x plus 70. So I need to calculate what that x value is. Y equals negative 2.8x plus 70. I already know my x value is 20. So I just plug that in, 2.8 times 20 plus 70. And when I do that in the calculator, I get a y value of 14. So I know this vertex is at 2014. My final vertex happens between my first two constraints, my red and my purple. To figure this out, I have to use systems of equations. So I have to set up y equals negative 2.8x plus 70 and y equals negative 7x plus 112. Now, remember, when we're doing elimination, which is what I want to choose to do, I need to get my x's on the other side. So I'm going to now rewrite these as 2.8x plus y equals 70 and 7x plus y equals 112. Now, if I want to eliminate my y's, which seems to be the easy part, I just multiply 1 by negative 1. My y's would then cancel. Negative 2.8 plus 7 is 4.2x, and that would equal 112 minus 70, 42. So then when I divide 42 by 4.2, I get my x value is 10. So I know at this point the x value is 10. Okay, kind of can see that by the graph, but because we had to guesstimate some of these dots, it's not exactly there, so you need to do your systems to get it exact. But now that I know x, I can plug it in. So y equals negative 7 times 10 plus 112, and that would give me 112 minus 70 is 42. Okay, so now I have all four of my vertices. So I get to now use my objective function to solve for what I need to know, to figure out how many planes I need to get to maximize my fleet. So now I need to take my vertices, and my objective function again was x plus y, right? So I need to take my vertices. I'm going to start at 16, 0. And I need to plug 16 plus y is 16. Then my next one was 20, 0. Well, 20 plus y was 0, sorry. 0 is 20. The next one was 20 and 14, right? So 20 plus 14 will give me 34. My last one was 10 and 42. 10 plus 42 gives me 52 planes total. So now I can answer my question. To have maximum fleet, my maximum number of planes that Federal Express could get out of these constraints is 52. And that would be 10 Boeings and 42 Fanjets or Falcons. Okay? And voila, you just solved your system. Due to time constraints, I am going to stop here, and I am not going to do the second equation in your notes. It works just the same principle, same concept, and you'll get just the same kind of answers. So I hope this helped, and you now have the rest of the time in class to do the 2 problems you have for your assignment. I hope everybody understood this video, and I will see you on Monday.